Alright, so today we're going to be reviewing graphing from Vertex form. The general equation, the general form of the equation in Vertex form is y equals a times the quantity x minus h squared plus k. So if we take a look at that a value, there's two things that number out in front of the parentheses tells me. It tells me what direction my parabola is going to open, so the direction of opening. And how wide or narrow the opening is. And when we say how wide or narrow, we're comparing it to the parent function where y equals ax squared and a would be 1. So when we say if it's wider, we're saying it's wider than a parabola with an a value of 1. Or if it's narrower than a parabola with an a value of 1. Because the a controls the growth. If a is 1, then we can just square our term and go from there. If a is a number other than 1, if a is a value greater than 1, that means we're having our growth go faster. So it's going to create a more narrow parabola. And if a is a number between 0 and 1, that's going to slow our growth down because we're growing slower and make our graph wider. So those are the two functions of a. The other two important letters in this format are h and k. And the reason h and k are important because this is called the vertex form. Those are the two letters that make up the ordered pair of my vertex. My vertex is the ordered pair h, k. Now, where some confusion comes in on this is because the equation says x minus h. When we go to identify h, if it's a minus, that means h is positive, and if it's a plus, that means h is negative. So it's going to be the opposite sign. So I'm going to put a little asterisk here and then put a little explanation over here. H is the opposite sign from the equation. And that is usually the one thing that trips people up because they want to go with, if it says x minus 3, they think, oh, h is negative 3. And it's not that. That means h is positive 3. But with k, it does go with the sign. If it's a plus number, it's a positive. If it's a minus number, it's a negative. The h value is the only one that goes opposite of its sign. All right, so the steps that we need to go through. First, we need to determine the direction of opening. Up if the a value is positive, down if the a value is negative. The next step, determine the axis of symmetry. In parentheses, I'm going to put capital AOS, how we abbreviate it. And that is found by x equals h. So whatever value we determine h is, that because the axis of symmetry has to go through the vertex, they share the same x value. And the reason we have to write it as x equals is because it is a line. So x equals some number gives us a vertical line. The next step, determine the vertex. And that is going to be, again, we already said it, that ordered pair H, comma, K. And then I've talked about this, about using the A value to find the next set of points. Now it only works for the first set of points after the vertex. But that A value does kind of act like a slope, but only for one set of points for us. So we're going to use the A value to find the next set of points. And again, what we're going to do there with the A value only works for the first pair of points after the vertex. After that, we would have to use a table of values or look at the growth, because we know that a quadratic function does not grow at a constant rate. So that A value only helps us get the first set of points, but that helps us get the general shape of the graph. Now, if you were asked to get more information, you would need more points. But just to graph it, that is enough information for us. All right, so let's now put all this to use. In graphing these. So the first one here tells us graph each quadratic function, name the axis of symmetry, or AOS, and the vertex. Mark the axis of symmetry on the graph. So the first equation they're giving me here is y equals the quantity x minus 2 squared minus 3. So I need to be able to identify my h value, my k value, and my a value. I need all three of those values. They all have a part in graphing this function. So let's start with a, because this is going to tell me if my function opens up or down. So what is the value of a in this particular equation? 1. There's no number in front of the parentheses, which tells us that it's a 1. So in this case, a equals 1. If a equals 1, is my function going to open up or down? Up. It's a positive, so that means we know that our parabola is going to open up. And that helps me as I'm sketching my graph, because if I'm getting values that aren't giving me an opening upward, I need to double check that I've done everything correctly. All right, what is the value of h in this equation? Now remember, h is going to go opposite of what the equation says. So if it's x minus 2, that means that h is a positive 2. What is the value of k? -3. K goes with whatever, however it's written. So h is opposite of its sign. K is its sign. So now, what is my axis of symmetry here then, based on this information? Okay, it's not just 2. Again, it is an equation of a line. So it is x equals 2. It is important when you're talking about axis of symmetry that it is written in an x equals. It is a vertical line. That's why it's an x equals, because it's a vertical line. So we go to 2 on our x-axis. Now the line needs to be drawn either as a dashed or dotted line. And the reason for that is whenever a diagram has a dashed or dotted line to it, it's what we call an auxiliary line. It's something that affects the function, but it's not an actual part of the graph of the function. So when we see a dashed or dotted line, it's just acting as a helper. So this would be the line x equals 2. That's the line that tells me that my vertex has to be on that line. And it's the line that divides my parabola into 2 equal halves. I have to have mirroring points on each side of that line. So what is my vertex here? 2, -3. It's just my h and my k brought together as my vertex. So I go to graph 2, -3, and again, I know it should be on my axis of symmetry because my axis of symmetry goes right through my vertex. Now, how we use that a? Since we said a equals 1, that is the same thing as 1 over 1. For the first set of points from the vertex, we can use that as a slope. So we're going to go up 1 over 1. Now the difference is on a linear function, when we say over 1, that always means to the right. Here, that over 1 means both right and left because we know we have mirroring points. So I start at my vertex, I go up 1, 1 to the right for 1 point, then I go back and go up 1, 1 to the left for another. So I can only use that idea of slope on that very first set of points. I cannot continue that to get more points. But this does give me enough to give me the general shape of my parabola. All right, problem number 3, y equals 2 times the quantity x plus 2 squared plus 2. So again, we need to be able to identify h, k, and a. And again, starting with that a value, what would be the value of a in this equation? 2. So is this going to open up or open down? Up. It's a positive. It doesn't matter that it's a 2. It's that it's a positive 2. So we know that this is going to open up. What is the value of h? -2. Because of that plus 2, we're taking the opposite sign. So it's a -2. And what is the value of k? +2. So what is my axis of symmetry for this function? X equals -2. H is -2, so x equals -2. So again, I'm going to draw in a dashed or dotted line at -2, a vertical line. So this would represent x equals -2. And what is going to be the vertex of my function? -2, 2. Again, I know that's going to be on my axis of symmetry because my axis of symmetry goes right through my vertex. And again, I can use that A value as a slope only for my first set of points. So if A is 2, that's the same as 2 over 1. So now I'm going to go up 2 over 1. And again, that over is going to be to the right and to the left because I need mirroring points. So from there, I'm going to count up 2 and over 1. And I should have points on either side of my axis of symmetry that are the same distance from the axis of symmetry. And again, that's enough to give me my general shape. Now, I know we said the A value determines how wide or how narrow. Graph number 2 had an A value of 1. Graph number 3 has an A value of 2. And yet they kind of look the same. The reasoning is the two graphs are not drawn to the same scale. You can't really compare the width of graph 2 and graph 3 here because the graphs are not scaled. If they were on the same graph with the exact same scale, our graph number 3 would be narrower than graph number 2 because we know if the A value is greater than 1, our graph becomes narrower because that means our graph is growing at a faster rate of change. And the faster it grows, the more narrow it goes. But the reason when you're looking at it right now, you really can't see that is because the two graphs that they are on are not scaled the same way. So that does impact how wide or how narrow they do look. But if they were to be on the same graph, scaled the same way, the graph we just did, problem number 3, would be narrower than the graph we did in problem number 2. Now, problem number 4, the graph is scaled more like problem number 2, so you are going to be able to see the effect that A has on the function a little bit better because of the scaling of the graph. So number 4, we have y equals 1/2 times the quantity x minus 3 squared minus 4. So again, we got to look at what is h, what is k, what is a. Those are the 3 values that are going to help us to graph this information. So what is the value of a in this equation? 1/2. Is this going to open up or down? Yeah, it's still a positive, even though it's a fraction, it's a positive value. Positive values open up, negative values open down. What is the value of h and k? So now, what is my axis of symmetry for this equation? X equals 3. So at 3 on my x-axis is where I'm going to draw my vertical dashed line here. Again, this is an auxiliary line that is not actually part of the graph of the function. It's just showing us where that function is divided in half. Since we know that quadratic functions are symmetrical, that is the line around which it is going to be symmetrical. And what is going to be my vertex here? 3, -4, just taking my h and my k. So I graph at 3, -4, I have my vertex. Here my a value was 1/2, so that's up 1/2. So from that vertex, I go up 1/2, up 1/2 to get the general shape of my quadratic. Now, when you look at graph 2, which is my graph in the green, versus graph 4 here, the graph in the orange, you can see that graph 4 is wider. You can see that effect, and it's because the two graphs are scaled more closely together than graph 3 was. So you can see how that number between A being a value between 0 and 1 is causing that growth of that parabola to slow down and causing it to be wider. All right, number 5. We have the equation y equals -3 times the quantity x minus 5 squared plus 3. So again, we want to identify h, k, and a. Those are the 3 values that will give us the information we need to sketch our graph. So what is the value of a in this? -3. So is this going to open up or down? Yeah, we finally have a negative value, so this opens down. What is my value of h? 5, and my k? So what is my axis of symmetry? X equals 5. So at 5 on my x-axis, I'm going to draw in my dashed line. That is the auxiliary line showing us where our parabola is going to be cut in half. And what is my vertex? 5, 3, just bringing my h and my k together. So on my axis of symmetry falls my vertex at 5, 3. A being -3 is the same as -3 over 1, so that is down 3 over 1. So from my vertex, count down 3 over 1 each direction. Give me the general shape of my parabola. So again, the notes and the homework are one and the same. So we did the first 4 here together. On the back side, there are 6 more questions. Those are the ones that you're going to be responsible for doing on your own. When the assignment is in Google Classroom later today, you need to make sure you're taking pictures of both sides of the worksheet. So you're really turning in your notes with your homework on this unit because they are going to be in the same document. You're still going to just take a picture of everything on this. So you have time now to get working.